Good afternoon, everyone. Today we're going to talk about accelerating the adoption of Datalake mostly for streaming and ML use cases. My name is Harsha Reddy, and co-presenting with me today is Adar. He's my teammate. He's the lead engineer on this project. We're from Doordash. Our mission is to grow and empower local economies. We offer multiple products like restaurant delivery and pickup, convenience and grocery. We have Dash Pass membership for discounts and promotions. We also do B2B fulfillment. What that means is if you order on Chipotle, it's DoorDash that fulfills it. So today's agenda is to talk about our journey from the data warehouse to data lake, and then talk specifically about our challenges at a high level, and then talk about our accelerator strategy. How are we trying to tackle these challenges? And then we do a deep dive. We're going to talk about our tools, our AI solution that's going to help us mitigate these adoption challenges. So here's the journey. We have two ecosystems right now. We have a warehouse ecosystem, which is a legacy ecosystem. Almost 99% of our workload still runs in the warehouse. We also have the data lake, and that serves a completely different cohort of use cases. So the common trend in the industry is that you want to reduce costs, at the same time you want to scale your decision making. So for those reasons, we want to find the right solution for the right use case. And the warehouse solution, it's very easy to use. And for data lake, some users find it complicated to understand the different offerings that the data lake can have. We do have a fully managed solution for the warehouse, which means our storage account is all linked to that one account. But with Data Lake, we have the isolation of storage compute. What we use for right now, data warehouse is used for analytics and reporting. Data Lake is used for DS and ML primarily, and for streaming. So our current journey right now is that we are in these dual ecosystems, and there are these, think of it like intersecting data sets that probably are needed for both ML, they're needed for data engineering use cases, they're needed for analytics use cases, and so on. What ends up happening right now is we're actually copying the data all the way from, we just keep copying the data back and forth. We do egress from data lake to a different system. We do, again, copies for some of these dependencies back to the data lake. Very inefficient, adds SLOs, adds to our latency, adds to our cost, maintenance, operational overhead. So what we're working towards right now, and this is something that we started working last year itself, and where we're trying to go is we want to have this common storage. And it might seem obvious, but there are a lot of intricacies in having a common storage between the warehouse and the data lake. Like, for example, we have too many options, like Iceberg, there is Uniform, there is Unity Catalog, Glue Catalog, HMS, and Polaris. There are multiple options in the mix. So the thing is, we are evaluating it, and we want to get to this stage. But taking a step back, this is where these are the basic stages of our data lake evolution. We've been through inception. We've done analysis of photon versus non-photon. We've checked out Iceberg versus Delta. We've done hoodie comparison. We've seen all formats. We've seen all catalogs to find the right fit, right? The different use cases where it works well, and in different other use cases it doesn't fit our needs. We landed on a right fit for our needs for now. We've defined a basic architecture. That's what is the long-term architecture we are working towards. The thing is, in the adoption phase, we are in the middle of an adoption phase, and what we've realized is it's very slow and it's very manual. It happens through like some experts and SMEs have to be in the room to get some of these issues resolved. There are a lot of these gaps that are discovered later when some kind of adoption or migration is happening. There's also this issue of users being aware of the system itself, because it's a new system. You're used to a different system, so that's another challenge. And then there's an expansion phase, which is what we plan to be in 2025, where we have cleared paired paths. We just want to be on the right course. So to me, the adoption is the make or break. Because let's say you have a parallel ecosystem, and if your users are not adopting onto it, then it just slowly gets phased out. So the first challenge that we have right now is the data readiness. Because you have dual ecosystems, you need to fix your ingestion first. You need to ensure data is available in both systems. One way to do it is parallel writes. You can do dual writes, very inefficient. Another way is to fix the way you ingest itself. So that's something that's a challenge right now. Not all data is available. Let's say for an ML use case, for streaming use case, we don't have the basic raw data itself to start processing it because it's going through a legacy line. The other thing is it's definitely time consuming and it's very resource intensive. It leads to a lot of, though we don't want to do these ETL migrations, it does lead to a lot of ETL and ML models that keep getting changed. They get move across storage layers, and yeah, so that's another big problem. And finally, we kind of control. I'm from the data platform / data engineering team, and we control some aspects of the models, but the consumption happens at a different level. And there's a lot of scope that gets affected for them, and they need to plan for that, those changes, and scope it. So what we're trying to do here is with Accelerator strategy, all we're saying is we know our bottlenecks, we know what tasks take a lot of time, and we're gonna fix each of them. We're gonna tackle them one by one, and we're gonna try to automate as much as possible. Where we can't automate, we're gonna use AI to assist us in this journey. So the objective is very straightforward. The mandate given to me and my team is reduce the total time to adopt by 3x. We are trying to hit 5x. So that's what we're trying to do. So we will talk about our AI. We're going to do a deep dive of what this solution is, what are these tools, and that's what Ada is going to talk about, each and everything. So let me talk at a high level. What's the role of AI in acceleration, right? The first thing is when you're in a dual ecosystem, the fundamental issue is with the data discovery and exploration, right? You probably need to know whether your data set is present in system A versus system B, whether all your dependencies are ready for you to build a new model in the first place. And the other aspect of it is exploration. Generally, our users don't care too much about where it's coming from, as long as they get the insight. They want to ask conversational questions. What were the number of deliveries in Moscone Center for lunch today? It's a simple question, can be answered with an ETL, with a data set. So that's another way we want to solve. So the way we produce the result can be from one of these systems or from multiple systems. So when I say multiple systems, we are on Pinot, we are on Trino, we are on like Snowflake, Databricks. We have multiple solutions in the mix. And the other one is SQL Copilot. You want to be having a translation. Like you want to have your SQL translation to be in parity because there are like so many dialects in there. Every system has its own version of an ANSI SQL compliant dialect. So that's something that we're trying to tackle with this the solution. And at the end of the day, you want to ensure that your users are consuming the right source of truth data sets. And that's another one that we're doing. So as part of our Accelerator strategy, what we're doing for the tools is very simple. We want to have a series of automations lined up so that it's like a car manufacturing assembly. Just don't worry about each and every step. Just go through a series of automations and you have your end product that's set up. And for new use cases, we're going to use a mix of AI and have these data readiness tools in place. So now the deep dive is going to go into these set of tools. We're going to talk about our inventory tool, which is the migration diagnostics. You want to understand what's the scope of a migration, what's the downstream impact, upstream's impact, before you head on to, let's say, build a new model within a domain. And this could be for streaming use cases, of any use case. The other one is a translator. So we're going to talk about our SQL translator, which supports multiple direct translations. And then the assembly tool, most of our orchestration happens in Airflow, so it's a migration kind of a tool. And then we have a data validation tool in play for reconciliation of the data. And finally, we're going to talk about Ask Data AI, which is our AI product that just covers all our acceleration pieces.
Thank you, Harsha, for explaining our overall strategy. And As per my part, I will talk about how we materialize the strategy into exact tooling. And I will explain some technical challenges and solutions that we applied to solve them. So to start with inventory tool, this is a data hub that is used to index all of our pipelines, tables, SQLs, sources, destinations, all this stuff. Essentially, this tool integrates data from Airflow, from Data Warehouse, from Datalake into one transactional database that is available for other tools to use. For example, inventory tool provides basic capabilities such as SQL extraction from Airflow logs. We're also analyzing dependencies for DAX, tasks, and tables based on these logs. It provides downstream impact analysis. So when some task or table is being migrated, it has to be analyzed for downstream impact. And this tool solves this problem automatically. It also implements table search. So essentially, when we are migrating from one warehouse to another warehouse or to Datalake, we have to provide overview of which tables has to be used in the target version of the pipeline. And parity inspection. As part of this tool, we provide capability to inspect schemas for each table that being used and to provide overall verdict whether this migration can happen or not. So in details, this is how our tool looks like. So in one interface, it's possible to search for docs, tables, tasks, and also it's possible to call different tools from the inventory tool. So to start with, there is UI overview about dependencies and downstreams. Also, you can implement downstream impact analysis with this tool. It's possible to automatically translate SQL dialect right from this UI. Also, it provides table health status, so we perform real-time validation of table in warehouse and in Datalake. It's possible to search in real time again alternative tables that can be used for the target pipeline, and it's possible to generate a code to migrate from one schema or from one framework to another framework. As part of the inventory tool, we have real-time health inspection feature. We call it inspection tool. So it's a low latency function that in real time provides overview of table volume parity, schema parity, and data freshness using Trino open source engine that is capable to execute queries over Datalake. Also, it provides schema comparison and, as I mentioned, data volume. And in UI, it materialized as a green healthy status of the both tables. So how we implemented? To create such a tool, it's essential to integrate data from different sources. So we're using Airflow database, where we have serialized version of each DAG. It also contains list of tasks, list of operators, and logs links. So logs from Airflow are very important because it's not always possible to extract SQLs that are used right from the operator definition. So logs always contain SQLs that are being executed. And by using logs instead of Python code, we can apply universal model to extract the SQLs instead of implementing support for each individual operator. So we also check source code, essentially for Python generation if we want to assemble a different version for a new framework of the existing pipeline. And we also have a Snow Datalake mirror service that is essentially a service that provides table mapping and metadata about tables across different warehouses and data lakes. So Airflow operators. Here you can see an example of how operator can be defined, and essentially it's not always possible to extract SQL from this. So we have to extract SQL name, then load the SQL from GitHub. So it takes time and not always possible. So we're using logs instead of that. We're also using SQL Glot. So to parse SQLs, we are using open source SQL Glot library that is capable to parse SQL AST tree, and from that tree we can extract tables and column names that are used. Next tool is Transaxle. So Transaxle is SQL translation tool. Databricks provides a library that is called SQL Glot and SQL Morph, I believe. And it's part of Databricks Labs project. So with this SQL Morph, it's possible to translate SQLs from other dialects to Databricks dialect. So for that, to wrap this open source tool as a product, we created UI that we call Transaxle. So it's a central hub to serve SQL translation needs. It's capable not only to translate to Datalake, it also helps us to optimize schema and to translate between convenient, conventional SQL warehouses. So it's capable to generate vendor agnostic SQL and provides capability to translate from any dialect, essentially. It considers table mapping, so while translating, it also translates, it finds appropriate table in the target data warehouse or data lake. We're using live Spark cluster to validate these queries, and we're also using LLM to generate summary about changes that have happened during this translation. Also, AI is used for solving problems when SQL can be translated directly with this tool. So in some cases, we need to apply some intelligence. Some intelligence to translate complex SQLs. So this is overview of how this pipeline works that I described. So essentially, remove SQL library from Databricks is used, and we created complex pipeline to translate any SQLs that we have. Next tool is assembly tool. Assembly tool is used for DAG generation. So it's a code generation problem that we have. So when we translate a pipeline and trying to migrate it or apply to Datalake framework, so we need to convert existing Airflow operators and DAGs to a new platform that we are going to use. So for that, we're using assembly tool. So this is how overall we automated code generation and new DAG generation. So essentially, we first extracting all SQLs that are used in the task and applying Transaxle for that. So now we have compatible SQLs. Next step is operator replacement. For each data warehouse operator, we have data lake operator that has exactly the same interface so that we can directly convert some portions of a DAG using simple regex replacement with new operators. Then we generate pull request in GitHub, and our unit tests are created to verify that new DAG can be executed in QA environment first. After that, we generate migration report, and essentially it contains all the changes that have happened and unit test execution results. So this is probably the most interesting part of our portfolio. So AI accelerators. With new LLMs introduced, there is a concept of agentic workflows. So essentially, when implementing some AI solution in the company, we are facing multiple security challenges, deployment challenges, evaluation challenges. And for that, we decided to create a platform for other teams to collaborate on AI problems and where they can apply LLMs to solve some of their problems. So problems include that teams solve. They need semantic search, essentially search by meaning, not by keyword. They need data interpretation of their problems. They need SQL query generation. They want to access complex data warehouse structures like metric cubes. That is not easy. It requires some learning curve. And AI can help explaining how it can be done. Also, problem include documentation search. So documentation is not always in one place. So some teams use Google Drive, some use Confluence. It can also be some Google Docs somewhere. So for that, we created as Data AI. So it's a platform that is essentially internal GPTs platform, like OpenAI GPTs, where you can create a custom AI agent with custom tools. We created the same for internal usage, so that other teams can utilize common platform like hosting platform, user interface, vector database, and semantic search engine. We provide integration with Slack and other communication channels. We provide REST endpoint and gRPC endpoint for querying these AI agents that installed in this platform. So essentially, from the internal team point of view, they have to create custom prompt, define semantic collections, define data loaders and workers to extract data from Google Drive, for example. They can define custom functions that are capable to call internal API endpoints so that these AI agents can access internal resources directly. So this is one of examples that we solve. So we have metric search problem. So we have a separate project called Firefly that collects all metrics from our company, and different teams collaborate on these metric cubes. So to work with them to implement a new metric or to access it, some learning curve exists, and essentially people have to learn how to query this data because it's structured in a specific way. So for that, we created AI agent that has certain tools and instructions how to work with metrics. So this AI agent is capable to search metrics. It can search general tables in warehouse and data lake. It can call get table description function. Essentially, it's SQL function to describe a table. And after calling all these tools, it generates final response and SQL recommendation for the query that was asked from the AI. Architecture. So what are agentic workflows? So we're using LangChain to be abstract, to use essentially open source standard for how agents can be defined and for how overall structure of AI is defined in this platform. So essentially, by agentic workflows, we mean that LLM does not directly provide answer. It's capable to think, to call functions, and if LLM decides that answer is ready, it generates final answer after that. So essentially, there is a framework that's called React, as per which it's possible to generate internal thoughts and actions. So for that, we're using LangChain to implement agentic workflow. Data accuracy problem. So while working with AI problems, we have to evaluate how well agent performs. And sometimes when we solve one problem, other previously solved problem occurs again because we change prompt. So it's very difficult to tune agent. For that, we need to implement some kind of evaluation engine that we did. So we encourage to use this engine for test-driven development. Essentially, in order to design a new agent, first test cases has to be defined. And another LLM is used to verify whether the answer matches expected answer from the test case. So this is the schema of how this AI evaluation works. Essentially, agent developer defines test case like queries and expected answers. And LLM model, after running this query on an agent, evaluates whether agent response matches expected response and provides evaluation score and explanation. So it's kind of approach of running unit tests for AI applications. Next solution that we created as part of Ask Data AI is semantic search. So essentially, it's very important to provide capability to search over data sets, dashboards, machine learning models, and all other assets that data engineers and machine learning engineers has. So for that, we created semantic search engine that is universally solves this problem for all assets that we have. From development perspective, developer has to automate loading data into S3 bucket, and data documents in this S3 bucket automatically indexed using semantic database. Currently, we are using Face library. It's from Meta, open source. And essentially, the goal of this semantic library is to optimally search for the right document based on user query. So we're also using OpenAI embeddings for that, to embed query into semantic representation, like vector representation of the query and documents. I want to provide another example of how AskData is used and why agentic workflow is the most appropriate form of implementation. So, for example, we want to migrate schema from one deprecated format to a new one. Let's say data engineers introduced a new data set. So how can we convert SQLs and pipelines to a new data set that were introduced? For that, we created agentic workflow. So LLM is capable to call certain functions like validate query, run query, and perform other steps as an agent to actually verify whether migration is possible. And if it's possible, it tries to implement a new query and compare results. And only if results are valid, it provides a response, the translated query at the end. So this is example of again agentic workflow usage. So yeah.
Yeah, that brings us to the conclusion. And it's pretty straightforward, actually. So what we're saying is the change is constant, and things keep evolving. Databricks just made Unity Catalog open source. Like a lot of changes going on in the community. So we got to keep, we got to keep changing fast, and we want to define the right architecture which is scalable for our own custom needs. And I'm assuming a lot of folks are on the similar journey here. You want to identify your bottlenecks, identify your solutions, custom solutions. Sometimes there are already existing solutions in the market. Go for them. And finally, don't underestimate the power of AI. Beyond the mainstream use cases, there are a lot of applications of AI in the data platform and in this migration and adoption world. That's about it. Thank you.